Hey guys, welcome to our Target 1C vocab video. 1C is all about theorems that involve similarity. So these are some cool applications with our similar triangle. So the first one is the side splitter theorem. And the side splitter theorem basically states if a line is parallel to the side of a triangle and it crosses through both lines, both the other sides of the triangle, then those triangles are proportional, right? So these are my two parallel lines. Without knowing anything about the triangle, I can say it cuts those triangles proportionally. What I mean by that is A and B are proportional to C and D. Okay? So I'm setting up that ratio. So as soon as I know those are parallel, I can set up a ratio with those sides. So that's a really nice theorem to have if you're not given angles or like angle, side, side, those things about a triangle. If you're just given their parallel, then you know you can still use proportions to solve it. Similar to that, this is a corollary to the side splitter theorem. Corollary is just something that's very similar to the first theorem. It uses the first theorem. You would use the theorem to like get extended a little bit. So this is very similar to that. But instead of a triangle, I just have two lines and then three parallel lines. Okay. So in the corollary, all three of these lines are parallel, and I don't care if it's a triangle or not. Okay. So it takes the triangle out of it and puts in another line. And then it's saying the same thing. I have a proportion here, or a ratio here, and a ratio here, and I can write this proportion. Okay? So anytime you see those parallel lines that are cutting things into equal parts, or I guess they're proportional parts, you can set up that ratio and set up that proportion to solve. Our last theorem that has to do with similar triangles and similarity is the triangle angle bisector theorem. So if I have a line that bisects an angle, any angle of the triangle, then it divides the opposite side into two segments, right? So here's my bisector, right? These angles are the same. It divides my opposite triangle, or my opposite side, into two sections that are proportional to the other sides of the triangle. And for this one, you have to make sure you go from the left to the right, right? C to D and A to B. Left to right, left to right. Okay? We can write that ratio. So that's another example. So that's another way, without really knowing too much about the triangle, not having to show that they're similar, that we can use proportions to solve triangles. That's it for our vocab for this target. So if you have any questions, let me know.